Welcome to the Fundamentals of Chemistry open course. My name is Dr. Mike Evans, and I am the instructor and primary developer of the course. In this first lecture video in the course, I wanted to talk a little bit about the overarching goals of the course and some of the unique approaches we're going to take to learning chemistry. And it really is all about the fundamentals. This is our primary goal. We want to establish the fundamentals on an almost automatic level so that when you get to more advanced coursework in introductory collegiate chemistry, organic chemistry, and perhaps beyond, you're going to have these foundations automatic in your mind. And so we'll talk about things like how we represent atoms and molecules, the key constituents of atoms that we need to keep in mind, ways we represent chemical change, chemical reactions, and physical changes like phase transitions from solid to liquid, liquid to gas, things like this. We'll talk about the central role that energy plays in chemistry and how we think about energy in chemical terms. And then we'll talk about what is undoubtedly the most important representation of molecules, the Lewis structure formalism. And then in the last module of the course, I'll lay down some tips for success in college chemistry, some common misconceptions about collegiate chemistry courses, and then we'll return to some questions that we asked throughout the course. As a fundamentals course, this is not a course that's going to answer a lot of deep questions about chemistry. However, these foundations are key for understanding and even asking these deep questions. So at the end of many videos in the course, there will be a set of what I'm calling lingering questions. These are questions that you may have asked yourself or may have come up as you're studying in the course that we're not going to answer here, but will likely be answered in your future coursework or asked in your future coursework with the goal of working toward an answer. Some of these questions are very, very big and are still an active part of chemical research, even at the highest levels. So these lingering questions are going to be a key part of the course in really building from the foundation that we're going to establish here. You're going to answer those questions later on down the line. There are many different ways to teach chemistry, particularly the fundamentals, the foundations, the basics. And as I was putting the course together, I landed on two things that kept coming up again and again and again that I wanted to focus on that are a little bit unique to this approach. And they're represented graphically on this slide. On the left, we have an image of some molecules. This is what we will call the submicroscopic level of chemistry, thinking about atoms and molecules on the single molecule level. We'll also call this the molecular scale. Thinking on this scale is really important for success in chemistry, but it's not something you'll often be explicitly asked to do. It's often something that you will do by reading between the lines in certain types of problems. But my claim is that it's going to help you. Thinking submicroscopically, even when a problem doesn't, put it in bold red letters, think about the molecular level, is going to be helpful in developing your conceptual understanding, which is just going to be a more efficient way to succeed in your chemistry courses. Thinking on the submicroscopic level is going to be key. On the right-hand side of the slide here, I just have a simple linear graph. And this came up in thinking about quantitative problem solving in introductory chemistry courses. One thing that you'll do frequently is you'll have a known quantity or a set of known quantities with known units, and you'll want to calculate something with a different unit, right? A different quantity, a different phenomenon in different units. And the way we sometimes do this is by taking what we know, multiplying by a factor that has the units involved as a ratio so that the units of what we know divide out and we're left with the units of the thing that we want to know. This is commonly known as dimensional analysis. And you may have experience with dimensional analysis from prior science courses. You probably do. We're going to rethink dimensional analysis a little bit in this course, referring to what I will call proportional reasoning. And proportional reasoning really focuses on that quantity that is the ratio of the two units and what it means, and whether it's just a conversion factor between two units where we're just rescaling kind of the number line. We'll see what this looks like actually in the first module, or whether this is something a little bit deeper, something that gives us insight into chemical phenomena, the way the natural world actually works. In either case, we'll use the same basic mathematical machinery of proportional reasoning, but it's that proportionality that's really the key quantity, and this is the beauty of proportional reasoning. If you learn to think in terms of those proportionalities, rather than this is what I know, this is what I want to know, how do I get from point A to point B, you'll develop a much more general way of thinking about chemical problems, and a way that, particularly in your introductory chemistry courses, and if you go on and take analytical chemistry where things are highly quantitative, centered around measurements, this is going to help you be successful in those courses. That's all I really wanted to say in this introductory video. We're going to get right into the first module right after this, learning about some of the foundations, the mathematical and scientific foundations we'll need to begin studying chemistry on a little bit deeper level. See you there.